Hello and welcome to this new video in the Learn C# series where I'm learning C# for my upcoming internship this summer, and I find teaching is actually the best way of learning. So we're kind of going through the C# 12 in a nutshell book over on O'Reilly Media, chapter by chapter, section by section, and where I learn a few new concepts, present them here on YouTube so maybe you learn something too, and as a whole we both get better at programming. Today, we're going to be covering parameter modifiers over in C#. This is a concept that is new to me. I don't see this in Java, I haven't seen it in C, and so I've prepared a couple of examples for you and I to kind of work through, and hopefully we can get the hang of what's going on with these parameter modifiers, especially when it comes to the reference in and out. With that out of the way, let's dive into the default parameter modifier, which is the pass by value. If you're new to programming, you might not know what parameters are. Parameters are variables that are passed onto a method. So here we have a method, static void print, and it has a single parameter that is of type string, and we're going to call it s. This again is just a parameter, something that's passed onto the method. And what we do with s is just print it out to the console. So if I create a string, let's just call it a maybe, and we'll say it's equal to Colton, and then I call print a, we're passing a as an argument to the parameter s in print. And so let's go ahead and just run that, and we get Colton. And actually, for the rest of this video, I'm going to go ahead and keep this print function. Now, there are a few other ways that we can pass arguments into a parameter or modify the parameter in some way in terms of how we're reading it, if we can modify it, and things like that. First, we have the default, which is passed by value, which is exactly what's going on here. We have no modifier on the parameter, so we're just passing in by the value. We're getting a copy of the reference to the string s, and that's it. In another case, we can have a reference modifier, which is where we're getting the same reference to the parameter, and how we work with that, how we treat that parameter is a little bit different than how we pass by value. Then we also have an out modifier and an in modifier, and as we get further into the video, those will be explained. Before we go on, let's take a little bit of a deep dive on the pass by value. Before we learned about modifiers, we were just passing everything by value. So we were just taking a copy of whatever the argument was, and then having our own local copy of that, modifying it however we want, and then once the method is over, it's done. We don't care about that copy anymore, and our original value up in where the original scope was of that variable is unmodified, unless we passed in some sort of reference, and then the underlying data could have been messed with a little bit. If you have any questions about that, I suggest taking a look back at some of my previous videos. So here in this instance, we have a pass by value, great example here. So we create an integer called num, and it's set equal to 1, and we call foo, passing in this number. So let's go take a look at foo. It's a static method, so we can call it from anywhere. It returns nothing through this void, and then it's named foo, and it takes in an integer called a. And so here in the method, we're just going to print out a, saying a is equal to whatever the value was, and then we increment a, and then we finally say, okay, let's print out a again. Now, what do you think is going to happen? Will num change or not? Before we even look at that though, let's just make sure that a is actually getting incremented correctly. So we run it, we receive that a was originally equal to 1, then it gets changed to 2. But what if we go ahead and add a console.writeLine for this num? So we can say num is equal to num right here, and what we're going to find is that num is still equal to 1 after this foo call. So again, a was received as 1, it got incremented to, but num is still remaining as 1. And just like I said, when we pass num over onto foo, num is copied into its own local variable in this scope down here. And so whatever modifications we're making down there is not going to reflect up here in the original scope. That's really the basics of the pass by value, the default way that we're passing around arguments in C#. Where it gets a little bit more difficult is when we introduce the ref modifier. The ref modifier changes things up a little bit. Instead of passing by reference where we're copying the value, the reference modifier is having us share a reference with the argument. Let's go ahead and go over what's happening in this code. So we have a public class cat. Every cat is going to have a name and an age, and then here's the constructor for that, just assigning the parameters to the fields of the object. So up here, we create a new cat called C. So it's named Mochi, and its age is 3, and we pass C, our cat, onto foo. So if we go look down at foo, foo takes in a cat cat called C, and then we set C equal to null. Now, if you've watched one of my previous videos, you know that this is again passed by value, and so that this C is just like a local copy. Like it's a reference that's pointing to also this C's reference, but if I change this C's reference, it's not going to change anything up here. And so let's go ahead and print what's going on. So even though I'm setting C to null down here, nothing should change up here. So let's go ahead and run it, and we still see that this cat right here, its name is Mochi and its age is 3. But what if we prepend the ref modifier to that? So if I say this parameter needs to be a reference, and then we have to say ref before the method call to, things get a little bit different. Now we are sharing the same exact reference to the same cat, and so whatever I'm doing to the reference down here in the method, it will also change it up in the original scope. So let's run this one more time, and we should get that C is now null. There we go. C has now become null. Now the ref modifier doesn't have to be with any like reference types or anything like that. Let's go ahead and just change this to like an int. So we just take out that, we say that we're going to take in an int x, and we'll just assign x to maybe 7 instead. And so let's go ahead and change this cat up here to an int. Let's just go with a, and it's equal to 10. And if we go ahead and pass on a, and we have to make sure that we have the ref modifier down here, that once we print out a, it's going to go from 10 and it's going to then print out 7. And there we go. X was actually, or a was actually changed to 7 because again, they're sharing the same reference to the same place in memory. The in modifier is very similar to the ref modifier. Instead, in says this can only go into the method, but we can't change it at all. Don't do anything with it, otherwise there's going to be an error. So we're back to our cat called C, and then we have another method called foo that takes in a cat C. If we change this to an in, this means that anything that gets passed in here, it's not going to change. Its reference won't change, so don't worry about it. And so we'll just go ahead and set C equal to null and see if there's anything wrong. Yep, we can't even do this because the right hand side of the ref assignment is read only. So don't even try to do this, and it's saying you cannot change this variable. Now what if we try to change its name? That is perfectly valid because C up here is a reference, but we can go ahead and access the underlying data and still change it. So if you want to prevent something from being changed, you might want to look into making some protected getters and setters over down in the cat class. Again, this doesn't have to be strictly with a reference type. We can have an int x, which is equal to 10, and change this to where we just take in an int z also. And so if we take out z and we try to assign it to a new number, we can't do it because whatever gets passed in cannot be modified. The last thing I want to cover here is the out modifier. The out modifier basically says I can take in an uninitialized variable and then I can produce or assign it before we leave the method. So here we have a cat C. It's not equal to anything. It's just a sitting null reference. Down here in this method, static foo, we're not doing anything with it, but let's go ahead and change this to an out cat C, which is going to say we are going to initialize C at some point in this method. Just make sure you do it before you exit. And so all we can do is just do C is equal to a new cat, and we can assign it again to Mochi, my cat, who's 3 years old, and then there we go, we're good. But we still can't print out C up here yet because we have it called foo on it. So let's go ahead and call foo and then pass in out C, and then you're good. Just make sure that you're putting out here saying that you recognize that there is some sort of variable that will eventually be initialized here. So let's go ahead and run this, and there we go. Cat C got initialized to Mochi with an age of 3. Another small nuance that we have here over in C# is that we can have discarded parameters. So what if we took an out cat C down here and then maybe also just like a string, so we can say out string and then we just call it S. Now we're not necessarily calling this, and down here we just set S equal to method for fun. And so here cat C is getting initialized, string S is getting initialized, so we don't have a compile error up here, but now we need to change something up here too. And so if I have a string, my string here, and we don't need to initialize it, right? We can just pass in right here out my string. But when it comes to discard parameters, we can actually just take out the C if we only want the string to come out of this method, and we can just replace it with an underscore. And so what happens down here is that we would get a compile error because C wouldn't get initialized because we're tossing it out here, but instead we can go ahead and print my string. So discarding parameters is basically when you know that you're getting multiple things back from a method, but you only want one or two of those things. And so here again, discard discarding C, but we're still getting my string back. So let's go ahead and run it, and we get method back because that's what we set S2 down in the method. Alright, that's going to do it for the end of this video. We covered all the parameter types over in C#, so that's ref, in, and out, and also kind of covered again what pass by value means, and gave a few examples of all of those. I want to thank you again for watching. If you don't mind liking and subscribing, that would mean a lot. I'm seeing that these videos are actually having some sort of impact, that there's actually someone out there that's trying to learn C#, so I hope these videos are doing something for you. So again, thank you for watching, and I'll see you in the next one.